Hello, today's daily lead code challenge question is best team with no conflicts. So it involves a little bit of dynamic programming, which we will see later. So in this question, we are given with two arrays, scores and ages, in which we have to return the highest overall score of possible basketball team. So a possible basketball team is a team where no conflicts exist, right? A conflict is when a younger player has a strictly higher score than a older player. So in that case, we can say that there exists a conflict in the team. So we have to form a team where no conflict exists, and we have to return the maximum possible score of that team. If we look into the example number one, we can see that ages are sorted in increasing order, and none of the score of the older player is less than or is strictly less than the players who are of uh, lesser age, right? In the example number two, as you can see that for age number two, I have two values 4 and 6. So I should select 6 here to maximize my overall score of the team, right? So how we can solve this problem? So for this problem, as we can see that for increasing age, the score must strictly increase, right? And if the age is same, we must select the greater score to maximize the team score. But in the case where both age and a score is same, we have to select all the players of that criteria. So for these two test cases, I can say this is the example which is given in the example number two of the question itself. So here age is given as 1122 and a score is given as 5546. So whenever the age is same and a score is same, we will select both of them because it will not make an conflict. But when the age is same but the score is different, so we will select the larger one because it will result in the maximum value of the team score, right? So let's take another example. We are given with an array of ages which is of 2 1 4 3 7. So to make things clear, what we can do is we can sort this combination of array on the basis of ages, right? So we will sort 1 2 3 4 7 in the order, and I will write the scores corresponding to them, right? So it will become 1 2 3 4 7, and scores corresponding to them were 4 5 6 5 7, right? As you can see that when we have to go in the increasing order of ages, my score must be of increasing order, right? So we can see that here it is 4, then it is increasing 5, then it is decreasing 6, but here it is decreasing. So I will not select this player. I will select this player. So these three will be selected earlier, and then this player will be selected. Strictly increasing when the age is increasing, right? So what we can see is here is that we have to find longest increasing subsequence from the scores if my age is sorted, right? Are you getting the point that where this longest increasing subsequence is lying, which is a famous dynamic programming question, right? So for this example, the answer would be 22. The maximum score for the team would be 22, and selected players are 4 5 6 7 having a score, and the selected players are of age 1 2 3 and 7. So I hope I am clear with my approach. So let's try to code this question in C++ and Java, and we will try to explain the code there. So let's move on to coding part. So what I have done in this question is that I have made a candidates array, which is a vector of pair, right? And the first value in the pair is mapped to ages, and the second value is mapped to the scores. Then after I am sorting that candidates vector on the basis of ages. Now I have made a DP array which will store the maximum sum of subsequence ending at I, right? So this is the logic which I have written here. We will try run this logic. So w- what I am doing is that I am calculating what is the maximum sum of subsequence ending at index I, right? So let's try to try run this logic of DP onto the example we have seen earlier, right? Now, for I equal to 0, dp of I will be the score of the first value. So it will be 4. Now, what it indicate is that at the index 0, the maximum sum of subsequence ending at that point is 4, right? So for I equal to 1, my j can go up to 0 to 1. 0 to less than 1, which is 0 itself, right? And it will check whether my candidate's I score is greater than equal to candidate jth score. So now in this case, the candidate ith score is 5, which is greater than equal to the previous score, which is at 0 position, right? So my dp of I, so this position will be maximum of dp of I, which is 5 in this case, as I have assigned this dp of I with the score of that point, comma dp of j plus dp of I, comma dot second. So it, sum of maximum sum of subsequence ending at index 0 comma 1, right? So it will become 5 plus 4. So it will be maximum of 5 and 9. So clearly the maximum ending at position 1 is 9. So it will become 9. So what 9 indicate is that maximum sum of subsequence ending at position 1 is 9. Similarly, if we go at index 2 here, so it will check that this score 6 is greater than 4, right? So when this is greater than 4, I will update that dp of I with the maximum of dp of I comma dp of j plus candidate score there, right? So it is 4 plus 6, which is 10 here, right? So it will be 10. Now my j will increase to the further value, which is 5. So it is indicating that maximum sum of subsequence ending at index 1 is 9, but here the candidate score at 3 is 6. So this will also be including in our maximum sum subsequence array at that point. So longest increasing subsequence. So what it will say is that the value will be maximum of 10 and 6 plus dp of j, right? So it will find that whether joining this candidate score is maximum than it is initially, right? So it will become 9 plus 6, which is 15, which is greater than the 10 value. So this 10 will be updated to 15, right? Now this 5 is less than the another values. So this 5, for this 5, it will check from index number 0. So it will check that for index number 0, 1, 2, 3, the first index 0 is less than 4. So maximum subsequence sum ending at 0, 1, 2, 3 index will be sum of these two. Am I clear? So it will become 9. Now Going forward, when j is 1, it will become 5, which is equal to the 5 value. So it will not include this, not include this. It will go forward and it will become 9 as it is. So it is also been visible that if we at index number 3, the maximum sum of subsequence increasing subsequence is 9, which will include this 4 and 5, right? But here we are interested in the maximum increasing subsequence. So going forward, I will I will find for I equal to 0 1 2 3 4. So for I equal to 4, what will be there? So firstly it will check that first index, zeroth index, is less than 4. So if is it is less than 4, it will find the maximum of dpi comma dp of j plus candidate's score there. So dp of I is 7, right? And maximum score there, maximum score with dp of j plus candidate score is that 11, right? So after j passes j equal to, for j equal to 0, it is 11, right? So let's write that. Now j equal to 1 here, right? So it will check that this value 7 is greater than the value score at this position, right? So if it is greater than this position, so it will check that maximum sum of subsequence ending there, can I include that? So if I include that, it will become 9 plus 7, that is 16, which is greater than the current value, that is 11, right? So I will include that. So it will become 16. Now j will forward to next step. So this j is also less than the 7 value, right? So it will check dp of j, that is the sum of maximum subsequence increasing subsequence at index j is uh, like if we add this 15 to 17, it will check for 15 plus 17 whether it is 15 plus 7 whether it is greater than the current value. So 15 plus 7 is 22, which is greater than this 16. So I will replace this 16 with 22, which will include these three elements plus this element, right? So it will update. Now now for like when my j become 0 1 2 3, j will become this, j will come at this place. So it will also see that 5 is less than 7, right? If it is less than 7, so it will check whether longest increasing subsequence ending at this position j equal to 3, whether including this index I am getting a larger value which is already present at that position or not. So I will add this 9 with this 7. This will result me in 16, which is less than this 22, right? So this 16 has not power to replace this 22, right? And I'm storing that answer into my maximum of dpi comma answer. So storing that answer into my answer variable. So it will become like at the last, after iterating all of the array, right, my answer will become 22, right? So my answer is 22 here, which is also been confirmed, right? So I hope you are clear with my dry run. So I have put a lot of time for dry run of this question, of this code. So I hope you understand this approach, and try to submit this question in java as well. As this video has become so long, so I am not including java in the video. I will add that java code into the description. You can go there and check that out. So I hope you are clear with the approach. Thank you for watching and see you in next one. And for this question, after this question, we have completed January long challenge, January daily challenge. So that is also a checkpoint which I have in my mind starting from this year. And thank you for watching.